In keeping with the theme of the last third of the semester, we're revisiting things from the first 2/3 of the semester and now looking at them in objects that have size and shape. We're going to do conservation of energy now. And the only thing that changes here is kinetic energy. And we have to realize that things can have kinetic energy even if their center of mass isn't moving. Think about spinning a top. You have to put a lot of force and energy into that motion, but then it just sits there. The center of mass isn't moving, but the entire object is spinning, and there's kinetic energy there. So we can no longer consider that just a point, because as a point, the top is staying still, but there is kinetic energy there. And the rotational kinetic energy, well, let's go back. Regular kinetic energy is 1/2 mv squared. And in keeping with the theme of just taking the rotational equivalence of everything, the rotational kinetic energy is 1/2. The rotational version of mass is mass moment of inertia I, and the rotational equivalent of velocity is angular velocity, omega squared. So now we're going to think of kinetic energy as a combination of the kinetic energy of an entire object moving, the center of its mass moving, 1/2 mv squared, that's the translational kinetic energy, plus rotational kinetic energy, the 1/2 I omega squared, that something might have because it's spinning. So how do we use this? We use this either in the work energy principle or in conservation of energy. So in the work energy principle, our governing equation is the total kinetic energy at state 1 plus the sum of all of the work between states 1 and 2 is equal to all of the kinetic energy at state 2. That governing equation isn't going to change at all. Only thing that's changing is we're adding this rotational component into the kinetic energy. And same thing with conservation of energy. The only thing that's changing is that our kinetic energy now has a rotational component. So our conservation of energy term was the kinetic energy plus all the potential energy. So that could be gravitational potential energy or elastic potential energy are the ones we've talked about at state 1, plus all the non-conserved work. So these are things that are not included in our potential energy. So friction and pushing pulling forces is our kinetic energy at state 2 plus all of our potential energy at state 2. Again, the governing equation doesn't change at all. The only thing that changes is our kinetic energy can now have a rotational component. So we're going to go back and revisit primarily conservation of energy, but also all the same things apply in the work energy principle, now just with things having rotational components.